the techniques for finding the maximum and minimum values of quadratic functions. This is a core component of the Cambridge Additional Mathematics syllabus. Understanding these stationary points allows you to model real-world scenarios like maximizing profit or minimizing the materials needed for construction. By the end of this lesson, you will be able to identify the nature of a vertex and calculate its coordinates using two primary methods: completing the square and differentiation. To determine the nature of a quadratic function, we look at the coefficient of the x squared term, which we call a. If a is greater than 0, the parabola opens upwards in a U-shape. This means the vertex is the lowest point, so the function has a minimum value. If a is less than 0, the parabola opens downwards. Here, the vertex is the highest point, and the function has a maximum value. Notice how the sign of acts like a smile for positive and a frown for negative. Identifying this is your first step in any exam question. Our first method is completing the square. We want to transform the general quadratic into the vertex form. In this form, the coordinates of the vertex are simply h and k. The value k represents the maximum or minimum value of the function, and it occurs specifically when the bracket equals 0, which is at x equals h. This method is highly favored in Paper 1 because it reveals the transformation of the graph directly. Let us apply this. We need to find the coordinates of the stationary point for the function. First, we factor out the coefficient of x squared, which is 2, from the first two terms only. Next, we complete the square inside the bracket. We take half of the coefficient of x, which is -2, and square it to get 4. We add and subtract 4 inside the bracket to keep the expression balanced. The first three terms inside the bracket now form a perfect square, x minus 2, all squared. Now, distribute the 2 back through the square brackets. Finally, simplify the constants. Since a is 2, which is positive, we have a minimum value of -5 at x equals 2. The vertex is at the point 2, -5. The second method uses differentiation. This is often faster if the question doesn't specifically ask for vertex form. At a maximum or minimum point, the curve is momentarily flat. This means the gradient, or the first derivative, must be 0. The process is straightforward. First, find f prime of x. Second, set it to 0 and solve for x. Finally, substitute that x value into the original function f of x to find the y coordinate. By solving for x, you find the location of the vertex. By substituting that x back into the original function, you find the actual maximum or minimum value. Let us use differentiation to find the maximum value of the function. F of x equals -x squared plus 6x plus 1. First, we differentiate the function with respect to x. F prime of x equals -2x plus 6. To find the stationary point, we set this derivative to 0. Solving for x, we add 2x to both sides. 2x equals 6, so x equals 3. Now that we know the stationary point occurs at x equals 3, we substitute this back into the original function to find the y-coordinate. F of 3 equals -3 squared plus 6 times 3 plus 1. F of 3 equals -9 plus 18 plus 1, which simplifies to 10. Because the coefficient of x squared is -1, the graph opens downwards. Therefore, the maximum value is 10, occurring at x equals 3. Let's tackle a typical Cambridge-style question. A curve has the equation y equals 3x squared plus 12x minus 5. Write the expression in the form a times bracket x plus b bracket squared plus c, and state the coordinates and nature of the stationary point. First, let's complete the square. We factor out the 3 from the x terms. Now, take half of 4, which is 2, and square it to get 4. We add and subtract this 4 inside the bracket. Multiply the 3 back through the square brackets. The expression is now in the required form. From this, we can see the stationary point occurs when the bracket is 0, so x plus 2 equals 0, meaning x is -2. The y value is the constant term, -17. Since the coefficient a is +3, the parabola is U-shaped, making this point a minimum. Even top students can lose marks on these details. When using the form a times x minus h squared plus k, remember that the x-coordinate is positive h, even though there is a minus sign in the bracket. If you have x plus 2 in the bracket, the x-coordinate is negative 2. When completing the square, a frequent error is forgetting to multiply the subtracted constant by the factor a outside the bracket. In our earlier example, negative 4 inside the bracket had to be multiplied by 3 before combining it with the outside constant. When using differentiation, ensure you substitute the x value back into the original function f of x to find the maximum or minimum value, not back into the derivative. The derivative will just give you 0. Always check the sign of the x squared term at the very beginning. A negative a means a maximum, while a positive a means a minimum. Don't let a negative coordinate for the vertex confuse you about the shape of the graph. When sitting your exam, keep these strategies in mind to secure every mark. First, always read the command words carefully. If the question says, by completing the square, you must show that specific algebraic process, using differentiation in that case might only get you the final answer mark, losing all method marks. Second, use the alternative method to check your work if time permits. If you completed the square, quickly differentiate the original equation. Both methods should lead you to the same x-coordinate for the vertex. Third, distinguish between being asked for the maximum value and the coordinates of the stationary point. The value is just the y-coordinate, whereas the coordinates require both x and y. Finally, always do a quick reality check. If your a is negative and you've labeled your point a minimum, you've made a sign error. This simple check takes 2 seconds and can save you from a major mistake. It is time to test your understanding. Please pause the video now and attempt these 3 questions. Take your time with the working. When you are ready, press play to see the full solutions. Let's go through the solutions. For the easy question, f of x equals x minus 5 squared plus 8. The function is already in vertex form. Comparing it to a times x minus h squared plus k, we see h is 5, 8. The vertex is simply 5, 8. For the medium question, f of x equals 2x squared plus 12x plus 10. First, factor out the 2 from the x terms. F of x equals 2 times x squared plus 6x plus 10. Complete the square for x squared plus 6x. Half of 6 is 3, and 3 squared is 9. F of x equals 2 times x squared plus 6x plus 9 minus 9 plus 10, which simplifies to 2 times x plus 3 squared minus 9 plus 10. Multiply by 2, f of x equals 2 times x plus 3 squared minus 18 plus 10, which is 2 times x plus 3 squared minus 8. The minimum value is negative 8. For the hard question, y equals negative 4x squared plus 8x plus 3. Differentiate. dy dx equals negative 8x plus 8. Set to 0. Negative 8x plus 8 equals 0 implies x equals 1. Find the y-coordinate. Y equals negative 4 times 1 squared plus 8 times 1 plus 3, which equals 7. The point is 1, 7. To justify the nature, we look at the coefficient of x squared, which is negative 4. Since negative 4 is less than 0, the curve is a downward parabola, making 1, 7 a maximum point. To summarize the essential points from today's lesson, first, always check the coefficient of the x squared term. If it is positive, you have a minimum. If it is negative, you have a maximum. Second, completing the square is a powerful algebraic tool that puts the function into vertex form, making the stationary point immediately visible. Third, differentiation provides a fast, calculus-based route to find stationary points by solving for where the gradient is 0. Finally, remember that the value of the maximum or minimum is the y-coordinate, which you must find by substituting your x back into the original equation.